So this is an example table. Here we collected, imagine that we collected 15 different samples. And in each sample, we collected 5 observations. Okay? So let's say that every hour I go there and I'm measuring, I don't know, the temperature of the burger in a Big Mac. Okay? So every half an hour, I take 5 Big Macs and I measure the temperature of those 5, and I write that down. Okay, so you're taking a measurement, you're doing samples, and you're taking a continuous variable, which is temperature, right? So I did that for the whole day, every half an hour. So I did 8, 8:30, 9, 9:30, 10, 10:30, blah, blah, so far and so on, until I have my 15, and I got all the data here from all observations. Okay, so for each sample, see here, we're going to calculate the average of the sample. So it's going to be the sample mean, just add them, divide by 5. And also the range, okay? So the difference here, the range, is going to be the highest value in the sample minus the lowest value in the sample, okay? So let's think about, this example number 4 here, okay? Sample number 4, the highest value is 10.81, the lowest is 10.59. So 10.81 minus 10.59, it's going to be 0.22. So that's what we're going to call the range, the highest minus the lowest. I put all these values here, and then I have the value that I'm really interested in. These are also important, but this is the one that is more important. The average of the averages, and that's what we call X double bar. So X bar is the average, okay, of the sample. That's called X bars, okay? And X double bar is the average of the averages, so the average of all of those. And also I have the average of the range, which is R bar. So bar is always the average, or always the mean, okay? So I have X double bar, the average of the averages, and I have R bar here as 0.22, X double bar 10.728. Okay, why is that important? Because I'm going to use that to calculate upper and lower control limits. So first we're going to do the X bar chart. And these are the formulas for upper control limit, the first one, lower control limit, the second one. So upper control limit is going to be X double bar, we just learned about him, plus A2 times R bar. We just learned about him too, okay? X double bar is the average of the averages, 10.728. And R bar is going to be the average of R, which is 0.22. Okay, so you know that. Pretty easy peasy lemon squeezy, as my daughter always say. Now, what is that A2? And let's not be, get confused about what that is, okay? So you're going to have this table is a standard value table. It's always going to be the same. And you need to figure out what is the A2 value for the N that you're using, okay? You can see that to change the N, you change the value of A2. And that's a standard table that we're going to use. And N, pay attention to this, I put it in red dotted lines. So red dotted lines is very, 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 very important, is the number of observations in each sample. So how many observations in each sample? Go back. It's not the number of observations. It's the number of samples, sorry. It is the number of observations in each sample. So I have 1, 2, 3, 4, 5 observations in each sample. N equals 5. N equals 5. A2 equals 0.58. And 0.58 is what I'm going to use here, okay, as A2. So if I know that, I know A2, I know X double bar, I know R, ta-da! I can calculate upper and lower control limits. So it's going to be 10.728, which is X bar, plus 0.58, which is A2, times a range, which is 0.22, and that is 10.856. Upper control limit, 10.6. Lower control limit. Now I can plot everything, and remember this is the statistical process control chart, and this is called the X-bar chart. Okay, X-bar chart. Now I'm going to plot all the sample means, and here are the means, and here are the sample numbers. So I have number 1, 2, 3, 4, 5 until sample number 15. And how do I get those dots? Well, let's go back here, and they are the X bars of each sample. So sample 1, that's the value of sample 2, 3, 4, 5, 6, 7 until sample 15, and these are the values that we put here, okay? And you can see there's a nice variation going in and out and up and down and blah, 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 blah. And question here, is the process under control? Yes or no? So hopefully you guys answer it very, very loudly. Yes, it is under control, because there is no dots outside the control limits. That's none of those samples were higher than upper or lower than the lower control limit. So we can say that the process is under control. Very good, guys. Good job.